Hello, in this video we're going to cover Boolean algebra structure. A brief history here. The English mathematician George Boole in the 1800s took Aristotle's system of logic and wrote Boolean algebra. And then Claude Shannon from MIT in 1938 took Boolean algebra properties and structure and used it to design and analyze digital circuits. So what is this Boolean algebra structure? This is similar to what we've seen in chapter 1 with and or in chapter 4 when we talked about set theory. So what is Boolean algebra? Boolean algebra is a set that has three operations. One are binary operation, which is plus and dot, which is or and, or union intersection, and the other operation, which is the negation. And we have two elements, 0 and 1, which in logic we call it false and true. So we have commutative property, just like we've seen with and or similar to what we know about algebra in general. 2 plus 3 is the same as 3 plus 2. But remember that this plus does not represent the addition, it does represent the or. And the dot represents an and. And then we have the identity, that means x plus 0 equal x, and we have complement property, x or x naught is 1. You could think about it as a set theory. When you have a or not a, that will give you universal set. If you have a here, outside is not a, so if I combine the two, I have everything, the universal set. Okay, or you could think about it with the logic true and false. So a complement property, x or not x is 1, as I said, and then universal bound, this is we need to prove. These are by definition 1a to 1,5 by definition, but this one here we're gonna need to prove it, so you could use it after improving other structure. So let's see, universal bound. What is universal bound? So if you want to think about it as a set, so you have A, that's your X, a set A, set of elements here. Union with everything, 1 is like universal set, 1 is everything. So A union with everything, that will give me everything, it will give me 1. So let's see, how do we prove this? Using the properties that we know. So we start from one side. And what is 1? I could use 5a. 1 is x or not x. So what I used is 5a. Or you could write complement property or just say 5a. And next, what I'm going to do, I'm going to use 2a, which is the associative property. Just move these parentheses. So when you prove things in your exam and in your homework, you must say how you go from one step to the other by using 2a. Just like where we did in previous examples in logic and set theory. And now, what is x plus x? X plus x is what we call idempotent in B4. So x plus x is just x, and what I use is idempotent. And we're going to prove this idempotent later. That x plus x is equal x using some identities. And now what is x plus x naught? As you could see, 5a, it tells me it is equal to 1. So I went from the left hand side, I get to the right hand side. Okay, this is the or. Then the and is very similar. It's just instead, we call it duality. Instead of a plus is a dot. Instead of a plus is a dot, and a dot is a plus. So very similar. When a to 5a is when b to 5b. They are very, very similar. So again, x and not x is contradiction, is 0. Or you could think about it as set theory. A intersect with not a, what do you get? Nothing, empty set. So empty set is a 0, or when you have contradiction is a 0. When you have 1 with the set theory, 1 represents universal set, everything there is in the world. And 1, if you talk about logic, 1 represents tautology, always true. And that's how we relate what we learned in chapter 1 with what we learned in chapter 4, now Boolean algebra, and we're going to use it to build circuits later on. So I'm going to try to prove universal bound. So you see this word dual, I mean, if I already prove it, I would just say that this is true by duality. What does it mean, this duality? I mean, I could use the exact same proof as I have here, but instead of 1 is a 0, instead of a plus is a dot. So I could do x dot 0 is the same as x dot x naught. Why? Because 0 is x and x naught. It's complement. And instead of 5a, I could say 5b. And then x dot x naught, and then use the associative law, which is instead of 2a, it is 2b. So we repeat the same thing. And then later on, we don't have to if the problem is exactly the same, except that the 1 becomes 0 and that 0 become 1 and the plus become that. So we just say, if you already prove it once, you say by duality it is true. So if I continue here, as you know, x dot x is just x, and also because of idempotent, the same power. And then x dot x is 0, x dot x naught is a 0 because of 5b. So as you see, the proofs are very, very similar, except that plus become that and that become plus. 5a is 5b and 2a is 2b and so on. So we don't repeat the proof twice, we just say it is true by duality. But here I wanted to show you what does it mean it's true by duality. That means you could follow the same steps. So the information of a Boolean algebra structure help us focus on the essential features common to all examples of Boolean algebra. And we can use these features, this fact, from the definition of a Boolean algebra to prove other facts about Boolean algebra. So what I want you to do is write all these facts right here, including idempotent, in your flashcard, because you're going to be looking at it over and over. You go from one side to the other. So majority of this section is proving Boolean structures. So the Boolean algebra is a set B that has, again, plus, dot, negation as operations, and then 0 and 1. How do we prove that x plus x is x? Again, we're not dealing with algebra here. It's not 2x, it's x, because a or a will give me a. So let's see. Here is the proof, but I didn't write down why we go from one set to the other. You could take a minute, stop the video, and write all the steps here by looking at the Boolean algebra definition and properties. So as you see, so what we use here is 4b, which is the identity property. And then 1 become x plus x naught. And what I used is 5a, which is the complement property. And then what I used here is 3a, which is distributive property. And then x dot x naught, that is 5b, complement. Right here becomes 0. And then x plus 0 is just x, which is 4a, which is the identity property. So in your test, you may be given this idempotent. I would say prove that x plus x equal x. Here is the proof. And you will be given those properties. You will be given this. You don't need to memorize, but you need to have in mind this for you. But you need to be familiar with these properties. So ordinary arithmetic, as I said, is not Boolean algebra, because in ordinary arithmetics, x plus x is 2x, but here it is x. So how do we do these proofs? So hints for proving Boolean algebra quantities. So usually the best approach is to start with the more complicated expression. Like here we started with x plus x, not just start with x. You can, but sometimes it's easier to start with something more complicated and try to show that it reduces to the simpler expression. Think of adding more form of 0, like x dot x naught. So like here I added a 1, which is x or x naught. So either you add a 0 or you add a 1 because of the identity. And remember the distributive property of addition over multiplication. Easy to forget because it does not look like arithmetic. Distribution doesn't look like the arithmetic we know of, so have that in mind. Remember the idempotent property. So x plus x is x and x dot x is x. So these are the rules for this Boolean algebra. I hope this is helpful.